Mrs. Larson is here. We are going to go over Module 10.02 in Algebra 2. This is on page 4. There are 4 practice problems we're going to go over together. So if you have done these, great. You can at least get a little bit more clarification with the explanations. If you haven't even done these yet, do them with me now with your piece of paper, and let's do this. All right, so this was number 1. And it says, what are the exact values of sine, cosine, tangent of angle theta if the point is 4, -3 is on the graph on the angle terminal side? All right, so first of all, let's kind of just look at where is this? It'd be a good idea to visualize where this point is at, and then where can we make our, I guess I just call it a trig triangle. So just to visualize where this is at, this is for -3, so we are in quadrant 4. This point is at over 1, 2, 3, 4, and then down 1, 2, 3. I'm going to go and put a point here. Again, to make your, I just call them trig triangles, we always want the base of the triangle to be on the x-axis, so that means I'm going to drop this segment down or over, and then drop the radius from the origin to that point. So this is our x, this is our y. We know we are 4 units over, so this is that, and our y is -3. We have a right angle here, so to find r, we do just need to use Pythagorean theorem. Or if you know your special right triangles, this is a 3, 4, 5. The radius will be 5, but to just show you what that looks like and why it is 5, we're just going to go leg squared, so -3 squared plus 4 squared other leg, and that's going to be the radius squared, and we get 9 plus 16 is equal to the radius squared. 25 is the radius squared. If you take the square root of 25, we get a radius of 5. Again, the radius is always positive, so now we know for a fact that this is a positive value of 5. So we've got our radius down, and now since we have that, we are ready to find the sine, cosine, and tangent. So again, the reference angle, or theta, is always, I guess, by the origin. And what I like to do is you can do your sine, cosine, tangent by using SOHCAHTOA, or you could use the fact that we know sine is y over r, cosine is x over r, and tangent is y over x. Whatever works for you. For this example, I like to do my, I'll do my opposite, adjacent, and hypotenuse. So just using my trigonometry. So whatever works for you again. So here we go. Let's try this one out. So across, or sorry, opposite of the angle, we have opposite. This would be the adjacent leg, and this is always the hypotenuse. So let's do this. So sine of theta is opposite over hypotenuse, so that would be -3 over 5. Cosine of theta is adjacent over hypotenuse, so that would be 4 over 5. And then lastly, we have tangent theta. This is going to be our opposite over the adjacent, so -3 over 4, opposite over adjacent, and there are all 3 answers. All right, so now let's move on to number 2. Again, if you need to pause at this video to just, write down and just collect your thoughts, no big deal, but we're gonna move on to number 2. So on the next little slide here, it says that we are trying to figure out which quadrants are each trigonometric function positive. So again, there's the 3 trigonometric functions, sine, cosine, tangent. The goal is to figure out, we want to describe the signs of the coordinate points in each quadrant. So this was in one of the slides in this whole module, but let's go ahead and dive just a little bit deeper on how to find these values, and then eventually we're going to use a mnemonic to know which trig functions are always positive. But if you have your coordinate plane here, we know that if we have any points in here, and we're going to relate this to x coordinate, the y coordinate, and then what would be, in this case, the radius. Well, the radius coordinate is always positive no matter where you're at, but the y coordinate in the first and the x coordinate in the first quadrant are always both positive. So if I were to write down my three trig ratios, cosine would equal, actually, sorry, I'm going to start with sines. I always like to go sine, cosine, then tangent, just like SOHCAHTOA. So starting off with sine, we have positive y over positive, positive r. So positive y over positive r, and that's a positive value. And then cosine is positive x over positive r, which is also positive. And then tangent would be positive y over positive x, which is still a positive. So in this particular quadrant, the first one, they are all positive. All three trig functions are positive here. So this is 1. We're in quadrant 2 now. So in quadrant 2, the x-coordinate is always negative, the y-coordinate is positive, and the radius again is positive. So I'm going to go through my sine, cosine, and tangent ratios. So sine, let me write those down. Cosine and tangent. So sine here would be y over r. So y over r, that's positive. Cosine would be negative x, because it's x would be negative, negative x over positive r, so that's negative. And then tangent would be positive y over negative x, so positive y divided by negative x, which is also negative. In this quadrant, the only trig function that is positive is the sine value, or the sine trig function. All right, so far we have quadrant 1 is all positive, quadrant 2 is sine is only positive, and now we are moving on to quadrant 3. So quadrant 3 right here. So again, let's start off with what our coordinate sine would be. So x in this case, in quadrant 3, all values x are going to be negative. Y values are also going to be negative, and the radius is still, well, positive. So doing this one more time, we have our sine, cosine, tangent. So sine would be negative y over negative r, so negative y over, positive r, which is negative. Cosine would be a negative x value over r, which is also negative, but tangent would be negative y over negative x, which would make it a positive. So in quadrant 3, the only trig function that is positive is tangent. And then our last quadrant, which is quadrant 4, our coordinate signs, x is always going to be positive, y drops down to the negatives, and then the radius is still always positive. So last quadrant, let's see what our signs come up to be. So sine, cosine, and tangent. So sine, in this case, would be negative y over r, which is a negative value. Cosine gets to be positive x, positive r, which is positive, and then tangent becomes negative y over positive x, which is negative. Negative divided by positive is negative. So therefore, again, only one of these values, one of these trig functions is positive. In this quadrant, it is just cosine. And so one way to remember this, if you notice that in quadrant 1 it's all positive, quadrant 2 it's only sine that would be positive, quadrant 3 would be tangent, and then quadrant 4 would be cosine. So one mnemonic, like they showed you in there, is just remember that starting with the quadrant 1, all sine, so this is all sine, tangent, and cosine. And so just to remember ASTC, we just remember the mnemonic, all students take calculus. And this helps us figure out the signs. All of them are positive quadrant 1, quadrant 2. Only sine is positive. T for tangent for quadrant 3, and then the fourth quadrant would be just cosine. So this is one way to remember that. So there we go. There's the answers. Which quadrants are each trigonometric function positive? So quadrant 1, all. Quadrant 2, sine. Quadrant 3, tangent. Quadrant 4, just cosine. All right, so now we're going to go back into our trig ratios for example 3. So let's go on. And this one says for an angle with the point 3,5 on its terminal side, what are the values of the sine, cosine, and tangent? So for this one, I am going to just, you can visualize what this looks like. You can use your trig ratios, but I'm going to try this a different way. This is just like number one, but I'm going to do this with just memorizing your sine, cosine, and tangent using the coordinates. So given here I have x and y. So let's see, I'll go ahead and just draw this out so we can see what's going on. 1, 2, 3, 1, 2, 3, 4, 5. All right, so here we go, right? Drawing out our trig triangle. We have 3 for this length, 5 up. We just need to find the radius. Now again, the radius, we have to use Pythagorean theorem, so 3 squared plus 5 squared is equal to, this will be r, so r squared. What we end up getting is 9 plus 25 is r squared, and this becomes 34 is r squared, so therefore the square root of 34 is r. So now we have a value here, root 34. So I'm just going to write down my coordinates. You could always call this theta and do opposite, adjacent, and hypotenuse, but knowing my coordinates, x is 3, y is 5, and then the radius is root 34. And I'm just going to go over, get my values for sine, cosine, and tangent. So in this case, just using the coordinates and the radius, sine of theta, I guess, would be, sine is always y over r, so that would be 5 over root 34. And then just rationalize this, so times root 34 on top and bottom. And so what we get is 5 root 34 all over 34. So there's sine, there's a ratio for that. So now let's get cosine. Cosine is always with x, so x over r, and that's equal to 3 over root 34, just plugging our values in. So times root 34 times root 34. And what we end up getting here is 3 root 34 all over 34. And then lastly, tangent is y over x. And for tangent, we get y over x, which is 5 over 3. Final answer. All right, so again, you guys just saw in example 1, actually in both of these examples, you could go with, your trig ratios with a trig triangle, or you can go with your coordinate ratios, which do follow the trig ratios as well. So those are just 2 different ways you can go about either of these. All right, last question is practice number 4. What is the value of sine and tan if cosine theta is 4 over 5? And, okay, so we do have a restriction, and there's 2 ways you can go about this. Like where are we? Because we need to know where we are according to the coordinate plane if needed, especially if, let's see here, all right, if you wanted to find out, let's see, what sign your coordinates are. So in this case, let's see, so there's 2 ways you could do this. You could totally convert these to degrees if you want, and if you did convert these to degrees, this would be 270 is less than theta is less than 360. So some people like to put that in degrees just so they know where they're at, because they know for a unit circle, this would be 0, 90, 180, and then this would be 270. So we definitely know we're in quadrant 4. Or you can go with the fact that we remember this would, in radians, this would be 0, this would be pi over 2, over here would be pi, so we're just adding pi over 2 for every, I guess, axis point, so pi over 2 pi, and add another pi over 2, which is 3 pi over 2, and then we're back to 2 pi. So again, we're still in quadrant 4, so we know for a fact we're sitting here. So if that's the case, what we're given here is cosine theta is 4 over 5. So if you think about your coordinates, cosine, this is x over r, which means our x value is 4, so this would be 1, 2, 3, 4, and then our R value is somewhere over here. So I'm just going to go ahead and draw a trig triangle. Whoops, let me make that a little bit bigger. There we go. And so we know that this is 4 units over this is 5, but that means since we're in quadrant 4, the y coordinate, since we dropped it down, or since we're in quadrant 4, the y value has to be a negative. And so let's go ahead and find out what that value is. So basically, what is this value right here? What is that length? This is a 3, 4, 5 triangle, but just to have you guys notice why it's a 3, 4, 5, I'm just going to go ahead and do the radius squared is equal to this leg squared plus y squared. And so I got 25 is equal to 16 plus y squared minus 16, I get 9 equals y squared. So now I get plus or minus 3 is equal to y. But because we're in quadrant 4, we just want the negative. So for sure, now we know, whoops, now we know y is negative. So I'm going to write down my coordinates over here. X is 4 given here. Y is negative 3, again, because we are in quadrant 4. And then R is 5 given right here. So to find sine and tangent, sine of theta is again y over r. So y over r would be negative 3 over 5. And then tan theta is y over x, and y over x, according to the coordinates I have here, that'd be negative 3 over 4. And there are the two answers. Bam, bam. All right, so just a little bit of, getting the visuals down, figuring out, all 3 of your sides, and then reverting that to, what we need, x, y, and r, and then plugging those values in for the trig ratios. All right, if you guys need any more help, you know where to find me. Miss Larson out. Thank you.